Hey there, this is me, Mohammed Vamik, and this is going to be your second class for grade 12 computer sciences. In the last class, we have discussed regarding data types, we have discussed regarding user-defined data types, why there is a need, why they are necessary, and I have explained to you the concept that why there is a need of that. So we are going to continue our last lecture from there. So basically, what we have covered since the last classes is what is data types, what is the need for them, why do I need them, what is the comparison of them regarding built-in data types or the user-defined data types. Then I discussed with you everything. I gave you the concept. I discussed with you in details regarding the objects and attributes. I even gave you an exercise based on that. So, in today's class, we are going to continue our lecture with the two different types of data types that we have right here. The first type right here is considered as a non-composite data type, and the second type of user-defined data type is going to be considered as a composite data type. I have two types of data types. One is a non-composite, and the second data type is basically to be known as a composite one. These are the two categories of that. And if I'm referring to a non-composite data type, it has two categories. It has enumerated data type, it has pointer data type. And if I'm referring to a composite data type, it has three areas. It is basically a record, a set data type, and objects or classes. So I hope that all of you are quite clear with the user-defined data types, that why there is a need of those, and it is basically divided into two of the areas. One is a non-composite and the second one is the composite. So now I'm going to discuss with you that what is a non-composite data type. So the two categories that first of all we are going to look forward is enumerated and pointer. So before moving into that, let's first discuss that what is a non-composite data type, right? So non-composite user-defined data type. So let's first check that what this concept really means. So if it is basically a non-composite data type, first of all, you need to imagine that you are making or building something with Lego bricks, right? Like for example, you can see these. Maybe if you have kids at your home, you have seen them playing bricks, and what they usually do is that they have many pieces of these blocks or bricks, and every piece is considered as a single block or a single object. But when I combine all of them, it makes up one object. It could either be a building or it could either be anything that you are trying to make. So if I'm referring to a non-composite data type, that means that I am referring to single units. I'm referring to single objects. I'm referring to individual bricks. That is simple and that is one piece. That means that if it is an object, you basically cannot break it down into smaller pieces. You cannot do that by yourself. So this is what the basic concept of a non-composite data types. The concept is that first of all, they are individual objects, they are single objects, they cannot be broken down into more areas, but many of them can be combined together to make the object. So I hope that the concept is clear, that what is a non-composite data type. So just in case if anything comes into your mind, so this is the basic criteria. This is the basic area, that this is a small piece of brick. So into that, I have two areas. So if basically it is a non-composite data type, so a non-composite data type is defined without referencing another data type. That means that it is purely on its own. It is not dependent on any of the value. That means that you are not referring to any other person, any other object, or any other data type. A non-composite data type is defined, is declared, is created without the reference of any other data type. That really means that you do not need to combine them. Like for example, in other of the examples, you basically combine a lot of data types into a single one to create the one data type. But right here, when I'm referring to a non-composite data type, you cannot do that here. That means that they do not combine different built-in data types into one data type. This is your first area. Other than that, the second area says that non-composite data types are the simplest types of data type which holds only single value and cannot be broken down further. Just like an example of a block, that it is single, it cannot be broken down further, and it holds these values. So, for example, if I just summarize this up, so what is basically a non-composite data type? A non-composite data type is basically a single unit. It's an individual unit. You cannot break it down into other pieces, but you can combine many of them to make the object. This is not something like you are combining different data types. A non-composite data type is only one, is only single. It can only hold single value. It cannot be broken down further. It is created, it is declared without referencing any other data type. I have two examples of that. One example is an enumerated one. The second example is an pointer one that we are going to discuss forward. Now, uh, let's check the more areas where I can help you understand this non-composite data type. So, for example, if I have a question like you need to define a non-composite data type, so you can understand it by this example that I have noted in this PowerPoint presentation, right? Like, for example, imagine you are making a recipe where each ingredient represents a different types of data. So, for example, flour could be an integer. For example, you are taking 2 cups of flour. For example, you are taking milk, but milk is definitely going to be in float because it is always calculated in terms of liters. For example, 1.5 liter or something. For example, if it's sugar, so sugar could be a boolean. So, for example, if it's with sugar or if it is without sugar. If you have vanilla, so vanilla could be extracted as a string. So if I have these four properties, so you need to understand that this is basically a non-composite data type. A non-composite data type, how is that? Because I'm basically not breaking it into more areas. These are single units, these are single bricks, but all of them are combining together than and making your recipe, making your perfect recipe. So these are basically to be known as an ingredients, right? For example, flour is two cups of integer. You are not breaking it down. This is simple. This is plain. We have milk, we have sugar. So this is one of the example where I can help you understand a non-composite data type. Other than that, I have another example for helping you. So basically, non-composite data types are basically like primary colors in a painting as well. For example, you can name it, right? Like for example, I have red, green, red, blue, and yellow. So you need to understand one thing here is that they are quite distinct. They are really simple, but basically you can mix them to create more complex shades and more saturations into that. That means that you cannot break down a single shade of color into more areas, but you can again combine them together to make the object. That means that these are simple areas that cannot be broken down. If I move ahead, you can basically think of a non-composite data type as an individual tool as well in a toolbox. For example, if in a toolbox you have a screwdriver, you have a hammer, you have a wrench, that is specialized tool, but a combination of them is completing the project. And you can also not break down a single screwdriver or hammer into any other of the tools as well. So I hope that the concept is basically clear to you of a non-composite data type, that what is it? It is basically defined without referencing another data type, and they don't combine different built-in data types into one data types. So let's carry on with the first example of that. The first example of non-composite data type right here is an enumerated type. So we are going to discuss this. So basically, if it is an enumerated data type, so if let's start discussing that. So if it is an enumerated data type, you can understand it as an enum. Enum is basically a data type that consists a set of named values. a set of named values. A set of named values means, for example, days in a week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Things like this that consist of a set. Enumerated type is a data type that consists of a set of named values, and each of the value is represented by an integer internally, but it used names to make the code easier to understand. It uses an integer but use names, right? Like, for example, if I'm referring to the number of days in a week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I have 8 days right here, but I have given them a value. Something like, for example, on one I have is Sunday, on two I have is Monday, on three I have is Tuesday, on 4 I have is Wednesday, and so on. So the point is that it is basically a list, but that list is basically provided to you with the help of an integers. So this is an enumerated data type. So what is an enumerated data type? That defines a list of possible values. A list of possible values means that what possible values means can fall into that. So you can see it right here. I have basically break it down. Like, for example, if it is enumerated, this enum, this enum is basically referred to as a list of named values. For example, the days of the week can be Sunday, Monday. Each one is a single simple value. So if it's an enumerated data type, it means a list of possible values, but you need to give a value to those values, right? An integer value. For example, 1, 2, 3, 4, 5, 6. So let's take another example of that, right, like think of enumerated data type as a predefined list of something. Imagine if you want to create a list of the days of the week in your program, you could use an enum to represent each day, and under the hood each day is going to represent it by a number. For example, 0 for Sunday, 1 for Monday, but you can refer to them by name. So basically, if it's an enumerated data type, you are referring to it by name, but internally or under the hood they are represented by some values. So, can you give any other examples of that? So, for this area, I'm giving you a time of 3 minutes to think onto that, and get me back onto this so that we can think of other examples of that. And your time starts now. Okay, so far I believe that you guys are done with your examples and enumerated is clear to you. So if I'm working with an enumerated, this basically means that I have a name constant. So this is an important one right here. Name constant basically means that instead of using numbers, you can use names for clarity, but under the hood, they are used for referring to these values. So enum can still contain multiple values, but they have to be values a single. And enumerated data type is like a list of name values. For example, the days of the week. So let's now work on to examples of that. So basically, what is an enumerated data type? It is again list of possible values. Now, for understanding and writing an enumerated data type, we are going to use the following pseudocode example. So this is going to be basically your syntax for writing this. So for example, type identifier is equals to value 1, 2, 3 that is going to be segregated by a comma. If it's a pseudocode of data type for working days, so it can be declared as T working days. So type names normally start with T to facilitate the programmer. So basically, I started the here type. I have written down my identifier. My identifier is type TW days, and then I entered all of the values. That is Monday, Tuesday, Wednesday, Thursday, Friday. So now you can see that these values are basically ordinary, and we can be using mathematical operators to make the comparison onto them. For example, it is not shown here, but in the programming it is going to be referred like on 1 I have Monday, on 2 I have Tuesday, on 3 I have Wednesday, on 4 and so on. So this is how you are going to declare a list when it's an enumerated data type, right? Like for example, you can see right here that variables can then be declared and assigned values. For example, now they have declared the work days. They have taken another variable and they have declared it as TW days. I have declared this day and they have declared it as TW days. I have declared next day as TW days. So basically, you can take any value variable. Your variable could be any name you wish to take, and you can assign them with an enumerated enum name of the variable, right? Like for example, right here I'm using the enum as TW days. So it says that today, next days. It's basically an example of count plus one. I hope that you guys are clear with the plus one. This basically means that now you are moving on to the next day. So it is important to note that the values of enumerated type look like string values, but they are not. Yes, it is important. They must be enclosed in. They must not be enclosed in quotation marks. So you need to understand the rule right here that if you are enclosing something in quotation mark, then perhaps it really becomes a string, but this is not going to be considered as a string since it is not going to have a quotation marks. For example, a comparison statement can be used with the values and the variable. For example, you have declared the weekend as boolean, then you declared the day as tw days. So that means that all of the values that were in t days is going to be assigned to the variable day. So they have made a comparison right here that weekend should be true if day is greater than Friday. That means that if you are having Saturday and Sunday, so it is going to be considered as true in your weekends. So this is going to be the concept of an enumerated data types. I hope that you understand the concept and you have also listed down some of the examples of that. And just in case if you have any difficulty, I have listed right here some of the examples, right? Like enumerated data types, some of the examples are like days of the week, traffic light colors, user roles into a system, right? Like for example, admin, support, manager, and seasons of the year that are like winter, October. It's like winter, summer, like this. So that's it for the enumerator type. The second type I have right here is basically to be known as a pointer data type. So basically, I use a pointer data type, and a pointer is basically a data type that is a variable that stores the memory address of another variable. Like instead of holding a value directly, it points to the location where the value is stored. So pointer basically means that you are pointing out to something. This do not store the value, it only stores the memory address of another variable. It do not store the value, it stores the memory address of another variable. That means that it is not storing a value directly, it is just storing the address. So I use a pointer data type when I want to reference a memory location. And I use a pointer. It's basically not a complex type. It's just like a simple piece of data. For example, you can also refer to as a simple piece of memory address as well. So efficient memory access and manipulation of data. Pointer basically allows you direct access to variables stored in a memory. Right, like for example, sometimes if you wish to store some data from your memory, but your main object is data. So if you want to store it, there can be two areas. One area is to store the data itself. The second area is that you store the address where that data is. So when you are storing the address where that data is, that means that you are not storing the data itself. And if you are not storing the data itself, that is going to be the efficient memory access. Because if you are going to store the data, it is going to store the data storages along with that. But if you're just storing the address of something, that means you're not storing the data, but you have the potential to retrieve that data because you have the address. A simple example of explaining you this is like, for example, if I want to meet my best friend, and perhaps I do not have the number of my best friend, but if I want to meet him, I can just go to his home and I can meet him. So that means that whenever I wish to meet him, I just go on to his home and I meet him. Right, that means that I know the memory location, I know the address. So this is to be known as a pointer data type. So for understanding that, you can imagine that you have a book, and instead of giving someone the book directly, you give them a map to the location where the book is stored. So that means that you are referring with an idea of that address. So that map is basically like a pointer. It points to where the actual book can be found. For example, if you want to have this book, but I'm not giving you, I just told you that you can find it here. So this is a pointer data type. As the name says, pointer. Pointer means that you are pointing this out to something. So pointer data type, the pointer data type needs to have information about the type of data that is stored into the memory location. In pseudocode, the type definition has the following structure. It has basically a cap sign, sort of a cap sign, which shows that the type that is being declared as a pointer, and type name. So for the syntax of that, you can declare a pointer, right? Like type a pointer and then the cap size along with a type name. So this is how you declare a pointer data type. For this example right here, I can see that how I'm declaring a pointer data type. For example, a pointer for months of the year could be defined as follow. For example, now the name of it is going to be type T month pointer and with a cap sign T month. Now this cap sign T months is that it is referring to all of the values that are considered in this variable, that is T month. So T month is going to be considered as a data type, and into that memory location, this pointer is going can be used to be point to. So T month can be considered as January, February, March, April, May, June, July. But instead of having all of the values, I'm just taking this value right here. So again, declare month pointer, T month pointer. T month is the data type in the memory location that this pointer can be used to point to. It can further be used like this. For example, month pointer, this cap sign. Other important areas is the if the content of the memory location are required other than the address of the memory location, then the pointer can be dereferenced. Dereference means that you are responsible for the contents of that. You do not want the memory location. So here is an example. For example, my month can be set to the value and stored at the address month pointer is pointing to. So you can declare my month as a T month, and then you can have this value to be declared in my month. So that means that if you are adding a cap sign just after your value, this means that this has been dereferenced and you want the actual value. So I hope it's clear to you that this pointer data type, that means that you are referring to a location of something, you are not referring to the contents of that. So again, I have some of the important examples of this right here. So for example, if I'm writing it just like this, like for example, type T integer pointer with a cap sign integer. So this cap symbol indicates that T integer pointer is a pointer to an integer. So in this case, T integer point can point to memory location that it stores the integer, right? It's simple. You can just go through that. For example, here is another example, but I do not have a cap sign. So this means that my integer pointer will store the memory address of the integer. So the cap symbol is not used here, as it is only necessary during the definition phase. That means that when you are starting to define your area, it is going to be used in the first phase. It is not going to be used afterwards. Other than that, I have example number three. Example number three states that declare number one, number two as integer, and then number one as 100. So the line declares two variable. I have number one, number two, both of the type is integer. It then assigns the value 100 to number one. So these are simple integer variables. The fourth example is like at the rate number one. This means that my integer pointer will store the memory address of number one, that allows the access to number one indirectly. So this symbol is basically used to retrieve the addresses, right? So you can make your own examples as well. For example, if you want to access some areas indirectly, if you want to have the memory location of that, so you can simply use this underscore sign. So as far as a little recap of what we have already discussed, so we have discussed in today's class regarding the enumerated data types, enums, that basically an enum is a list of named values. For example, the days of the week, but they are given a single and simple value. They are given a number, but that is not shown. Other than that, what is a pointer? A pointer is basically a pointer does not store data directly. It stores the address of where the data lives, from where you can get that accurate data. I gave you the example of that book. For example, if you're finding a book, but instead of giving you that book, they just gave you the location of that. So this is a non-composite data type because it's just one thing. It's a memory address. Other than that, I have some questions of this as well. So I hope that non-composite data types are clear to all of you now. You are clear that why do we use a user-defined data types? What are the reasons for that? Why it is necessary? You are clear with the concept of a non-composite data type, that is basically means a single bricks, but they can be combined together to form a new structure. A non-composite data type belongs you with an enumerated one. An enumerated stands for a list of possible values, and if I am referring to the pointer data type, the pointer data type basically means the memory location which can be used to refer to the contents. So I hope it's clear to you. Thank you so much, everyone. I'll be uploading some resources onto that. You can review to that, so it would be clear to all of you. Thank you so much, everyone.